Hello guys, this is Engineer Selassie from Hello Academy and Brain Boosters, and this is the second video. You can check my first video about the introduction about operating systems, and as you know, we are going to use the operating systems 3 easy pieces. This book was published by Remzi and Andrea, the University of Wisconsin. So this is our first book, our primary book. So we're gonna start. So today we are going to start chapter 1 and chapter 2, and I'm going to use Linux, Ubuntu for the source course. And as I told you, please go to this website, and it is a free source, and try to download the textbook and all the source which we need for this course. So let's get into it. So all the source code, you can go here in this GitHub and you can download it. So today our focus will be here, just a dialogue on the book. This is chapter 1, and chapter 2 is introduction to operating systems. So we have virtualizing the CPU, virtualizing memory, what is concurrency, persistence, design goals, some history, summary, and references will be presented. And let's get into it. So as I told you in my first video in the introduction, you have to download and install this virtual machine and Unix. For this purpose, we need Linux, Ubuntu. So you can download and use it. Okay. So I gave you a video link also. You can go to this video link and you can download Ubuntu 2022. And because this book is, we have a lot of source codes and we have to execute it and we have to see. So it is good for you also to practice. So chapter 1, this is just a dialogue on the book. Even if it is a dialogue, it will give you a lot of knowledge what the idea of operating system. The student is discussing with the professor. So mostly in this chapter 1, student and the professor discuss, and the below points were discussed. Those are the 3 key ideas we are going to learn in this book: the virtualization, concurrency, and persistence. And I encourage you to go through and read the book in chapter 1. And in learning about these ideas, we will learn about how an operating system works, including how it decides what program to run next on the CPU, how it handles memory, overloading virtual memory system, how virtual machine monitors work, how to manage information on disk, and even a little about how to build a distributed systems that work when parts are failed. Those sort of stuffs are discussed in chapter 1. I encourage you to go and read it because we have a lot of things to do. So let's continue. So chapter 2 is an introduction to operating system, 3 easy pieces. And in chapter 2, introduction to operating systems. This chapter in general will be the introduction part. What is operating system, how it does, what it works, and something like that. So the first issue is what happens when a program runs. I hope everybody knows what a program means and when the program runs, what happens. And I assume that you took some background in programming language. I assume that. But if you don't have any knowledge about programming also, I advise you to take courses. When a program runs, it executes instructions fetched from memory by a processor. The processor decodes each instruction and executes it until the program completes. The processor figures out which instruction it is through a process called decoding. Instructions can include tasks such as adding two numbers, accessing memory, checking conditions, jumping to function, and many more. After executing an instruction, the processor moves on to the next instruction in the program and continues the process until the program is complete. So we have von Neumann modes of architecture computing. So in this program, in this lecture, I'm assuming you know this. So if you don't have knowledge about von Neumann model of architecture, please go through this link. This is a video. The basics of how a program runs are described by the von Neumann model of computing, so you can check here. Opcode in short is operation code. It is a primary code that represents a significant specific instruction that a computer processor can execute. Opcodes are stored in memory and tell the processor what operation to perform. Each CPU has its own set of opcodes, and the format of an opcode may vary depending on the instruction set architecture of the CPU. Programmers typically don't write opcodes directly, but instead use high-level programming language that are compiled or interpreted into machine cores. So in general, as per the von Neumann modes of architecture, before any program executes, all its codes should be stored in the RAM, read access memory. So mostly read access memory, our RAM is like 8 GB, minimum of 8 GB, sometimes 16 GB and 32 as well. But all the programs should be stored in the RAM. Then from the RAM, the CPU will access and process it. So operating system, the operating system is responsible for simplifying the use of the computer. It achieves this by enabling programs to run easily and efficiently, allowing programs to share memories. Again, enabling programs to interact with devices such as printers, scanners, and cameras. Without the operating system, running multiple programs simultaneously would be challenging, and it would be challenging for programs to communicate with devices and use available resources. So in general, with our operating system, the definition of operating system is an interface between the hardware and the user, and it will achieve, operating system is in charge of making sure the system operates correctly and efficiently and in an easy to use manner. It is an interface. The basic definition of operating system is it's an interface between the user and the hardware. The user uses APIs, application program interface, to utilize things which are provided by the operating system through APIs, system calls. So we will come up in that a little bit later. So how the operating system is performing all these tasks, which are for enabling program to run easily and efficiently, allowing program to share memory, and enabling program to interact with devices such as printers, scanner, cameras. Without the operating system, running multiple programs would be challenging. So how the operating system does this? How the operating system does this? So the idea of virtualization comes into picture. This is the main secret. So virtualization The primary way the operating system does this is through the general technique that we call virtualization. So in the virtualization, physical resources like processor, memory, disk, okay, these are virtualized by the operating system. The virtual form is more general, powerful, and easy to use. This allows the operating system to be referred to as virtual machine. In general, virtualization allows the operating system to take physical resources such as a processor, memory, or disk and transform them into a more general, powerful, and easy to use virtual form. The operating system takes a physical resource and transforms it into a virtual form of itself. What does it mean? It means the virtualization means the operating system creates some form of virtualization. For example, if you have one CPU, one central processing unit in your laptop, then the operating system, it makes it infinite number of CPUs. That is what we call it virtualization. Okay, the program thinks it has its own RAM, its own CPU. Okay, so in that way, each program when it runs, it assumes that it has its own hardware by itself, the processor, the memory. So that is a virtualization, very powerful concept, and we will show you in a minute. So because operating system provides us calls to run programs, access memory and devices and other related actions, we also sometimes say that the operating system provides a standard library to applications. That means, as I told you, system calls, the operating system is an interface between the user and the hardware. So the user uses system calls to access the aim. You see, the operating system provides standard library. So to access the utilities in the operating system, the user should use a system call. So system calls allows user to tell the operating system what to do, and the operating system provides interface called APIs, standard library, application program interface, for the user to communicate with it. APIs allow user to utilize features of the virtual machine, such as running programs, allocating memory, or accessing files. A typical operating system exports a few hundreds system calls available to applications. System calls enable the operating system to provide a standard library to applications. The standard library allows applications to run programs, access memory devices, and perform other related actions. To access APIs in Linux, we use man page, in which a command line man system, and we shall see that in a minute. And the most important thing is operating system is an interface between the user and the hardware, and the system call is which allows the user to tell the operating system what to do. So to access these libraries, we use in the Linux we use man system calls. Let me go and see in the Linux. Okay, as you can see, this is my Linux. Just log in. Log into Linux, and let's open the terminal. Let's open the terminal, and once we are in the terminal, as you can see, we can use man syscalls. So if you see man syscalls, this is Linux program manual, syscalls, Linux syscalls, and you can read the syscall is the fundamental interface between the application and the Linux kernel, system calls and library wrap functions. System calls are generally not invoked directly, but rather via wrapper functions in this like PC. So you can go through and read all these are the kernels, and this is the system calls. As you can see how many system calls we have. How many system calls we have. So in this is the system calls, and okay, let's open the terminal. So what we are going to do, the first thing what I want to show you, man syscall, as you can see. Then if you go and see what is the system calls, and this is Linux, so you can go ahead and read how many system calls we have, and all these are the system calls, as you can see. And if you want to see the man page, as you can see the manual page, so an interface to the system reference manual. This is the description. As you can see, we have two. This is the system call which we have, and let's go and see. For example, let's choose one just to see. Let's choose from the manual. For example, close or this clone, create. For example, let's create it. Let's see, this is the version 1. So let's see. Okay, create. So what we can do, man to create. So as you can see, this is what it does. Open, this is create, open, and possibility create a file. So you can go ahead and read. If you see open system call, open the file system by this, and that's what it does. That's what it does. So in this way, you can go and you can go ahead and you can read how the system calls are working.